Hi guys, welcome. Today we're having a look at matrix multiplication. So I want you to be able to recognize when you can and can't multiply two matrices, and I want to know have you be able to do it. Right. So we're going to look at an example, Sydney v Melbourne. Took it from the textbook, obviously flawed. Melbourne firstly wouldn't be down, and not by that amount of the first quarter. Nonetheless, we know to work out the total score, the total points, we'd say 12 times by 6, and then we add that to 15 times by 1. We know a goal is worth 6, a behind is worth 1 in Aussie football. Similarly, we say 9 times by 6 plus 10 times by 1, that gets us to 64. We can represent this information in two different matrices. So the first matrix I'm going to draw is to represent the score. So here will be goals, here will be behinds, this will be Sydney, this will be Melbourne. Right, so Sydney kicked 12 goals, 15. Melbourne's kicked 9 goals, 10. I can use another matrix to represent goals and behind. For the sake of the exercise, I'm going to use a matrix as a column matrix. And so in my column matrix, I'll say the number of goals and the number of behinds. Right, so if you try and follow here now, what I'm going to do is the same thing as what I did before to work out the total, but just using our rules of matrix multiplication. So the first thing I'm going to do is say 12 times by 6. Right, so 12 times by 6, and then we need to add that to 15 times by 1. And that's going to give us the total score for Sydney. I'm going to put this into a matrix as well. Similarly, what I can do is say 9 times by 6, and then I can add that to 10 times by 1. And all of that is going to give us the total score for each of our teams, as we know. 12 times by 6, 72. What I should do first, do an extra step in here. 12 times by 6, 72. What's going on there? 72 plus 15. 12 6 is 72, 15 times 1 is 15, 9 6 is 54, plus 10 times 1, which is equal to 10. And we add that all up, we're going to get 87 and 64. Right, and that's the same as what we've ended up with in the example. Right, and so this is ultimately this is matrix multiplication. So let's take a look at what we've done. So this guy here was a 2 times by 2 matrix. That's this guy here, the one that's got the goals and behinds in it. The one that tells us 6 and 1 was a 2 times by 1 matrix. Now matrix multiplication tells us that the number of columns in the first matrix has to be equal to the number of rows in the second matrix. Right, so columns of 1 has to be equal to rows of the second one. So the columns, remember when we say 2 times 2, that means 2 rows, 2 columns. So we must have this number here has to be equal to that number there. So columns of 1 has to be equals to rows of 2, which this does in the first case. Often I get confused. I can't remember whether it's rows of 1 has to be equal to columns of 2. Just remember that C comes before R in the alphabet, so columns equals rows. Columns of 1 equals rows of 2. We ended up getting out a 2 times by 1 matrix, and the reason that works out is that the number of rows in the first one times by the number of columns is what we get out of a multiplication matrix. Right, so that 2 is equal to that 2, and that 1 is equal to that 1 over there. Cool, so that's generally the first things that we need to know. Let's go have a look at a couple of other main examples. Before we do though, I might just put that down into notes so you've got something to copy in. So let me pause and add those into notes. Alright, so we've got that there now. In matrix multiplication, the number of columns of the first matrix must be equal to the number of rows in the second matrix. So the number of columns here was 1, 2, and the number of rows was 1, 2. So those two things must be equal for it to work. The size of the resultant matrix will be the number of rows of the first. Rows of the first is 2 times by columns of the second, which is 1, and then the resultant was a 2 times by 1, 2 rows, 1 column. when multiplying, each row of the first matrix needs to be combined with the columns of the second matrix. Now I've used the word combine, that's a pretty general term there now, and we're going to have a look now at how exactly we combine those things. Alright, so we've got two matrices, A, which is equal to A1, 1, so it's A row 1 column 1, A row 1 column 2. This is what the matrix will be, row 2 column 2, and then B, and that is made up of B row 1 column 1, B row 1 column 2, B row 2 column 1, B 2 2, and we want to know what is the value of A times by B, or AB. Alright, and so first of all we need to check whether the rows of this guy is equal to the columns of this guy is equal to the rows of that. So does columns of A equal to rows of B? There are a number of columns here, the number of columns is 1, 2, 2 is equal to the number of rows here is 1, 2, 2 is equal to 2, so we're happy days. Alright, so now we need to combine these things together, and let's take a look exactly at how we combine those things. Alright, so the first thing we do is have a look at the first row here. Alright, and so if we're comparing this back to the football example, we took this and times it by this, so the number of goals times by the value of a goal, the number of points times by the value of points. And we're going to do the exact same thing here. Alright, so A1, 1 times B1, 1. And then we add that to A1, 2 times by B2, 1. B2, 1. Right, and then when you take the row of this guy and have a look at the column of this guy. So again we take A1, 1 and we multiply it by B1, 2 this time. And that will form, so that's our first element, it's the first element here. And then our second element will be A1, 2, and we're multiplying that by B1, 2. And then we get A1, 2 and multiply it by B2, 2. Plus A1, 2 and multiplying that by B2, 2. I might pause there and just fill in the rest of it. And so what, what we've got here is our completed matrix. So this guy here is this row times by this column. This guy here is this row times by the second column. This guy here is this row times by the first column. And then this guy here is the second row times by the second column. And I think the best way to practice this is by using actual examples. But the last thing to say is, for our notes, is that in general, the value of AB does not equal the value of BA. Alright, and we'll hopefully get a chance to see that in some future worked examples. Cool, so let's take a look at some examples now. Just before we do take a look at examples though, I just want to have a look at one other way of thinking about this. And this is just a quick way that I tend to now look at matrix multiplication. So this times by this is equal to this here, and we use that addition. Then we go this times by this, and that's equal to this here. Then we say this times by this, second row first column is equal to this, and then we say the last thing we haven't done. So we haven't done the second column and the second the second row and the second column. That's equal to that guy there. Alright, example time. So an example here, we've got A, which is equal to this 2 by 2 matrix, and X, which is a, what's that, number of rows, 2 rows, 1 column, so 2 by 1. Let's just put that in. 2 by 2 and a 2 rows by 1 column. Find the value of A times by X, and then find the value of X times by A. So first of all we want to check if columns of the first is equal to the rows of the second. We don't need to write anything for this, but we can look at the columns of the first, which is this guy, is equal to the rows of the second, so that's all good. So now what we want to go ahead and do is apply the multiplication. Now to do that, the first thing I do is sub in the matrices. So we've got, in this case, a times by x, and that's going to be equal to a, which is 6, 4, 5, 7, times by x, which is 3, negative 2. Just while we're thinking about it, this is going to be the resultant will be a number of rows, so 2 times by 1. The rows of the first, column of the second, which is the opposite order of whether or not it does multiply together. So when we're seeing if it does multiply, we look at that and that. In this case, to see how big the resultant will be, we look at the rows of the first and the columns of the second. So it would be a 2 times by 1. So size of resultant will be a 2 times by 1. And now we need to go ahead and apply those laws. So we say this row, this row times by this column, and then this row times by this column. So we have 6 times by 3 plus 5 times by negative 2, and then 4 times by 3, so 4 times by 3, so this row times by this column, and then adding that to 7 times by negative 2, and then we want to simplify. So simplifying here, we'll do it in 2 steps. First step will be 6 times by 3, 18, plus 5 times by negative 2, so it would be plus negative 10. And then 4 times by 3 is 12, plus negative 14. So that's 18, plus negative becomes a negative, 18 minus 10, which would be equal to 8. And then 12 plus negative 14, so 12 minus 14, which would be negative 2. And there's our answer for AX. To then look at x times by A, so part B, we want to check if columns of 1 is equal to rows of 2. Oops, I probably should have done that a little further down. But B, so the columns of 1, this time x is 1, so columns of 1 is 1, and then rows of 1, sorry, that should be rows of 2. So columns of 1 there's 1 column in the first one, and then because we're looking at x times by A first, so x becomes the first matrix. And then A, we need to look at the number of rows in A. Number of rows is 1, 2. And 1 does not equal to 2. So since columns of 1 does not equal rows of 2, or you could even write columns of x does not equal rows of A, then XA does not exist. There's our answer. We'll look at one more example, and I'll find some free space to do that on. So again, when we're looking at this first example, Mn, we want to check if the columns of M are equal to the rows of N, and they're both 2 by 2s. So if they're both 2 times 2s, we're all sweet there. So what we're going to do is have Mn, and we'll sub in matrices. So where we write M, we write the matrix M. So where M is, we'll write the matrix M. So 3, 4, and 5, 7. And then where we've got N is -5, -3, 3, and 4. Next thing we've got to think is to apply the multiplication. Now this is a pretty big step when we apply this multiplication, as it was in the last one as well. I think it's just going to happen through practice, right? So it's going to need practice again and again and again. But generally the way we look at it is we say this column, this row times by this column, and then the same row times by the second column. So we're going to make sure that this first row, the way that I think about it, this first row has to be multiplied by both of the columns. And then the second row also has to be multiplied by both of those columns. So let's give that a go. Oops, that's in yellow. So we say this 3 times by -5, and then 5 times by -3. That's that 5 times positive 3, so that 5 times by that 3. Right, so that and that is our first element in the matrix. Then we say this times this, and just getting used to whereabouts each one of these goes. So this one and this one go in the top right hand corner. So you say 3 times by -5, that's 3 and -5, and then 5 and, that's a mistake there. That should be, 3 times by -3, and then 5 times by 4. I'm adding it to 5 times by 4. So that's that, and that, and that, and that. Now we've got to do the second row. So the second row has to be multiplied by each one of these two columns. So we're looking at 4 times by -5, and then 7 times by 3. And then we're saying 4 times by -3, and that's being added to for 7 times by 4. We simplify and state the answer. So 3 times -5, -15, and that's added to 15. This guy -9 plus 5 times 4 is 20. And this one here, -20, 4 times -5, -20, 7, that's meant to be a times there. 7 3s are 21. 4 times -3 is -12, plus 7 times 4 is 28. So we simplify that in the next line down. So 0, -15 plus 15 is 0, -9 plus 20 is 11, -20 plus 21 is 1, -12 plus 28 is equal to 16. And that's our answer to MN. Just note that here, if we did n times by m, which you might want to do yourself, hint, we wouldn't get the same answer. Wouldn't necessarily get the same answer. But there is our answer to MN. The next question was getting us to look at m squared. So m squared, we need to check if it works. So we need to see if the columns of m equal to the rows of m, because we're looking at m squared both this time. They're both, it's a 2 by 2 matrix, so it's going to work out. And then we want to substitute in. So we say m squared. Another way of writing that, which is maybe a little easier, is n times by m. Now let me just scroll up so I can see what m was. M is 3, 5, 4, 7, and that's multiplied by itself. Alright, so 3, 5, and 4, 7. I'm going to pause and accelerate through for the sake of time. And there's our result there, just taking a quick look at what each thing is. So that times by that is this. Then that times by that is this. Then that times by that is this guy here. And then finally that times by second one is this one here. And we can chase that all the way through. That one's going to be the same as that one. Yellow is that guy and that guy, and then our purple one is the bottom left one each time. Hopefully you can still see the answers to each of those. I might need to rewind and pause. No definitions for today. If you're a little confused by this, no stress. I think the best way to practice this skill, or best way to learn this skill, is just going practice, practice, practice. So when we get into class on this skill, really important, you just try and smash through as many of these different questions as you can. And that's particularly important when we get things that are bigger than 2 times 2, right? So we get it looking at 3 times 3s and beyond. All right, good stuff. Thanks, guys.